Alrighty, so for the first time in this chapter, we're now going to start to hit some new material. Today's concept is similar to a procedure that you should have learned in algebra, which is why Algebra 2 was a prerequisite for this class. You should have already finished Algebra 2. When you learned how to solve for two unknowns, if you had two equations, one of the techniques that you learned was that you could actually add the equations together. And if you added the equations together, a lot of times you could eliminate one of the unknowns and then be able to solve for the other one. So we're actually going to be doing something very, very similar to that with the equations for chemical reactions. Now, when he does this in the book, he writes everything out, and he probably does that just because he can't talk to you like I can on video. And so he writes everything out and he color codes things. But when you work the problem, you don't need to write all that out. So I'm going to show you how to do that. Basically what happens is that when you have an example 1.4, which is on page 6, basically we've got a chlorofluorohydrocarbon. When we destroy these chlorine atoms, that hits it by ultraviolet light, and then the chlorine splits off from the rest of the molecule. And then that atom reacts with ozone. And so that's where we're picking that reaction up at. So I have a chlorine atom that's hit by an ozone molecule, and then it gives me these products. I then take the ClO and then hit that one with a free oxygen atom, and it's then going to form chlorine plus oxygen in the form of O2. So this is basically a two-step reaction, and when it happens in more than one step like this, I call that a reaction mechanism. Now, what I can do is I can add these two equations together and say, what's the overall result of doing these two things together? When you write these two equations out, one thing that you want to be very cautious about is to make sure that your arrows are always on top of each other, because that's going to make it much easier to see what's on the left-hand side and what's on the right-hand side. Once you have that done, it's pretty easy just to start canceling things out. So here I have a ClO on the right, and here I have one on the left, so I can mark those out. I also have a Cl on the right, and I have a Cl on the left, so I can mark those out as well. Okay, I don't have anything else in common, so what I can do is then I can add those together, and so here I have an O3 plus an O on the left-hand side is going to give me, I have an O2 and another O2, and so I can write it as an O2 with the 2 in front of it, like that, simplified form, okay? Now he goes through like 3 or 4 lines in order to get you to this point, but as you can see, that's not necessary. You can just draw a simple slash mark through things that you're canceling out. Go ahead and count those up and put a 2 in front of it together. It's gonna make that much simpler. He does also mention this particular piece. He mentions that chlorine is a catalyst. It starts out to get the reaction going, but it doesn't end up as a product anywhere. I mean, it does end up as a product, but it's something that it starts out and it ends up here. And so it's not used up, it's not produced, but it's necessary for the reaction to proceed. So that is a catalyst. Well, does that mean ClO is also a catalyst because it was produced and then it was on the other side and I canceled it out too? So is that a catalyst? What do you think? Well, if our definition of catalyst is something that's necessary to get a reaction going, the chlorine would fit into that category, because if the ozone here doesn't have anything to react with, obviously the reaction is not going to take place. This one was not necessary to get this first reaction going. So even though this was produced and then used up, this is not a catalyst because the reaction proceeds without it. So chlorine is a catalyst. This ClO is not a catalyst because it wasn't present at the beginning. Okay. Now, In this example, we did two reactions that we added them together. You can do that with more than one reaction or with more than two reactions. You can do it with three reactions. In fact, in practice problem number 5, which is part of your homework today, you will be doing it with 3 reactions. So just stack them all up together, cancel out just like we did here, combine like terms just like we did here, works exactly the same way, okay? So that is adding chemical equations.